Welcome to our third video on the binomial distribution. In this one, we look at the mean and variance. You may remember from statistics that the mean in a distribution or data measures the central tendency of that data, roughly what's in the middle, what's expected. And the variance is a measure of how spread out is that data. Before we do that, here's a little starter for you, which I'm going to pause the video for a second to consider. Well, the answer to the first one is easy, that's 1 over 6. But it's the same for the second one, because x squared equals 36 can only happen if x equals 6. And x equals 6 can only happen if x squared is 36. So it's 1 out of 6. And the same for this one, for the same reason. And this question, 72 times 1 over 6 is 12. That's the expected value. It makes sense, doesn't it? A sixth of the time you would expect to throw a 4. Therefore, a sixth of 72 times is 12. We're going to prove that formula today. And here's where we got to in the last video. The formula for the probability distribution function of the binomial distribution. And we want to know two formulas today for the mean and the variance. Actually, we're not going to prove them, we're just going to conjecture them. We're going to see some evidence for them, which turns out to be fun. Okay, so if we start with this simple example, where we have the binomial distribution with parameters 1 and p, what is the expected value? Well, we've done this before. The expected value is the random variable value times its probability plus the random variable value times its probability, and that's p. So the expected value is p. In fact, it's 1 times p. Same thing. Okay, so it's just that times that plus that times that. That's always the procedure. I'm going to pause the video for a second for you to do the same for this one. Well, we proceed exactly the same way. 0 times q squared plus 1 times 2p q plus 2 times p squared. And that gives us 2pq plus 2p squared. There's a common factor of 2p, and I get q plus p. But remember, q plus p is 1, so we've got 2p. Therefore, the expected value, is 2p. Good. Same thing for 3 trials. I'll pause for you to do this one. Same again. I'll just do this quicker. 3q squared p plus 6qp squared plus 3p cubed. Take a common factor of 3p. We're left with q squared plus 2pq plus p squared. That's 3p, p plus q squared. P plus q is 1, so we'll end up with 3p. Fun. Okay, so we can see if x is distributed binomially with trials 1, we get expected value of x is 1p. If it was 2p, we get I think you may be able to see a pattern. What's that I hear you say? Yes, it's NP, okay? NP. Okay, so that's our evidence for that formula. Let's talk about the variance. Now to do this, we have to just dip into higher level for a moment and use this. You won't have to use this in the exam, but it's a nice exercise today. Now, the variance is the expected value of x squared minus the expected value of x squared. It sounds the same in English, but look at the brackets. It's a different thing. We already know this from the previous slides. We've done that. It's this one that's new. But on the first page, we saw the event of x squared equals some value x squared has the same probability as the table we did before. X squared can only equal x squared if x equals x, and vice versa. So these probabilities just don't change. Now to find the expected value of x squared, we proceed as usual. 0 times q plus 1 times p, which is p. And the formula tells us the variance of x is the expected value of x squared minus the expected value of x squared. That's p minus what we did previously, p squared. Common factor of p, 1 minus p, which is pq. So the variance of x is pq. In fact, it's 1 pq. Superb. Let's try it for 2 trials. Okay, I will pause the video in a second for you to work out this. Okay, so what is it? 1 times 2 qp plus 4p squared. So if we take out a common factor of 2p, we are left with q plus, wait a minute. No, we can do this a bit quicker. Which is 2qp plus 4p squared. But we know the variance of x is the expected value of x squared minus the expected value of x squared, which is 2pq plus 4p squared minus this squared. Do the math, you'll get 2pq. So the variance of x is 2pq. It gets even more fun with 3 trials. We won't have time for 4, but that's life. Okay, so I'll pause the video again. Can you work out these things? And therefore this thing? Okay, expected value of x squared, you should get 3q squared p plus 12qp squared plus 9p cubed. Common factor of 3p gives you this. Q squared plus 4pq plus 3p squared. Look at that closely. it's a quadratic in disguise. 3p q plus 3p q plus p. Our old friend q plus p, which is 1. So we get 3p q plus 3p. Therefore, the variance, if I multiply that out, I get 3pq plus 9p squared minus this squared, 9p squared, and that's 3pq. Okay, let's just summarize our results. Oh, I put the answer there. Okay. So there's the answer. In other words, NPQ. I'm sure you saw the pattern anyway. Good. So one question we're going to look at now is what value of P makes the variance maximum? That's all we've got time for today.